Good evening everybody, a very good evening to all of you bachcho. We are back with another session of control system training using Matlab, and this time we will be discussing the use of lag compensators in Matlab. That is how you can design a lag compensator based on the system design requirements. So we know whenever we design a control system, we have certain criteria, we have certain parameters that we need to satisfy, and based on that we need to figure out what compensator can we use in order to satisfy those parameters. So that is what we will be discussing in this session, that is how can you figure out the poles and the zeros of a compensator based on what design parameters you need to satisfy. So guys, before we start, do hit that like button and share as much as possible, and if you still have not subscribed to the channel, do subscribe to this channel because this is the best channel on YouTube for electrical and ECE students. So let's get started guys. So let me start by introducing myself before we go any further. My name is Ankit Goyal. I got AIR1 twice in GATE exam in 2014 and 2018. I was awarded President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes, and I am currently working as a director at Unacademy for GATE department. Now, most of the students know this about me, but guys, what I always want to tell that Unacademy and Kreatryx team, they are a revolution in the field of GATE education, in the field of technical education. Why? Because we provide the maximum amount of free content to the students. And why do we do that? Because we believe that no student should be left without education. Every student has a right to basic education, and that is why we reach out to such students and we help the students in need by providing them quality education at zero prices. And those who can afford, they can always come to Unacademy Plus subscription. Now my friend, our free initiatives are not at all restricted to YouTube. They are also available on the Unacademy learning app. So don't forget to download the app from the Play Store or the App Store. Don't go just now. Just see this video. After that you can download, and then you can unlock any free initiative simply by using the code AnkitESC. This is the invite code that says that Ankit Sir has invited you to the platform. Now my friend, if you want to watch my Unacademy free classes, visit this link. Here in the upcoming section, you will find all the classes that I will be taking in the future, and you can watch those classes. And in case you want to watch the content that you have missed, then you can watch it recorded in different folders based on the thing that you want to learn. And in the special classes, we have a very special initiative for you, that is Master Blaster Practice Series. In Master Blaster Practice Series, you are getting 10,000 practice questions before GATE exam, so that when you enter the examination hall and you face the question, you will always feel that you have seen this question before and you will be able to crack it very easily. Okay, so let's get started guys. Lag compensator. Now you might have studied lag compensators in theory about control system, and if you have not yet studied it, then make sure that you go through it. Last year I taught the entire control system on this very YouTube channel, and you can watch that playlist, okay, to get an idea about lag compensators. Okay, and this year Pankaj Singh sir has already taken control systems live on this YouTube channel. You can watch that as well, whatever you prefer. Now what is a lag compensator? A lag compensator is a combination of a pole and a zero, where the pole and zeros are such that pole will be nearer to the origin. Pole is nearer to the origin. So that is why you call the 0 as minus 1 by tau, and this is minus 1 by alpha tau, where alpha is greater than 1. Okay. So now my dear friend, what is the use of lag compensator? It provides a phase lag. What is phase lag guys? It is a negative phase shift. So what we do is actually we connect a lag compensator before the plant in the forward path. Suppose you say that the plant transfer function is Gs, the feedback is Hs. So you will connect the compensator between the summing element and between the plant. So after the summing element, first compensator will come, then plant will come, and then we will be having a block of feedback. Now this compensator will provide you a negative phase shift, and why do we do that? That is, we need to do because we need to justify the requirements of the design. We need to satisfy whatever parameters we have taken for the design. We need to make sure all the parameters are getting satisfied. Now this is the electrical network realization of a lag compensator, where you see across the output we have a series combination of R and C, and there is a resistance at the input. So if you find out V0 by Vi very simply, then it will be of this form, where tau is R2C and alpha is R1 plus R2 over R2. And as I told, alpha is greater than 1, it is R1 plus R2 by R2. Okay, so we are not going into too many details about the theory, like lag compensator can improve the settling time, rise time, all those kind of things. I'm not getting into that. For that, you can watch my control systems playlist. Let's see how we can design a control system with a lag compensator using Matlab. So guys, let us say we want to design a transfer function GS having a following requirement: settling time less than 5.5 millisecond and overshoot equal to 16.4%. So this is my design constraint. That is, these parameters must come into the design. So now, as I told you in the lead compensator part as well, you first need to design a control system, transfer function, like in this case it is 1 by s plus 3, s plus 6. After which, what you need to do, you need to use the CISO tool. So let's directly switch over to the Matlab and see if we can do this. Okay, so here we have the Matlab. So let me write G equal to TF. This is the numerator. The denominator actually has convolution of 3 terms. Okay, 1, 0, and this will be convolved with s plus 3, s plus 6. Okay. So see, now the transfer function is fit here. I will write CISO tool G. Let's see, the control system designer should open up. So in the last video, I explained you conceptually what all steps you need to do in the Matlab. Let's see if this time we can directly do it in Matlab. So I think it should open up. So today what I have done differently as compared to the last video, this time I haven't opened any more tabs, any more softwares are not running. So only this Matlab is running because this is a very heavy tool. So see, you get a Bode editor where you get a magnitude plot, a phase plot, you get a root locus, and you get a step response. That is, in CISO tool you get each and every information about the control system. So let me work with the root locus. So let us say I maximize it. Okay. So see, this is the root locus of the system that we have fed into the Matlab. Now the first thing that you need to do, you need to set the design constraint. So design requirement new. The first is settling time should be less than 5.5 seconds. Okay. So this yellow region, this indicates that in this region your settling time is less than 5.5 seconds. So this region is your region of interest. Then in another design requirement, I will write the peak overshoot to be less than 16.4%. Okay. This all is given to me as a design criteria. So if you see, this is a straight line through origin. Why? Listen to me very carefully. Your peak overshoot, basically, this overshoot is what? It is exponential for second order system. I am writing down, right? So basically it is a function of zeta. So if you take peak overshoot equal to constant, that means zeta is constant. Now when you take zeta as constant, what will happen is you will get a straight line like this. Okay. Why like this? Because this angle is theta and zeta is cos theta. So you will get a line inclined at an angle theta, and this also is possible. Why? Because complex roots exist in conjugate pairs. So that is what we are getting in Matlab. This value, this inclined line represents what? It represents a constant value of zeta or a constant value of overshoot. What does this straight line represents? Like, let me show. Settling time is basically 4 by zeta omega. If this is constant, then zeta omega n is constant. Now when we talk about the roots of a second order equation, it is minus zeta omega n plus minus j omega d. So what you can say? Real part of roots is constant. So real part of roots is constant, and that is why we are getting a vertical line. Understood? Because the real part of the roots is constant. In a root locus, what are the axes? Y-axis is the imaginary, x-axis is the real. When we say real part is constant, we will get a vertical line. Now the actual game begins. See, you can move over these points, and you can see when you move these points onto the root locus, basically, just let me see if I can grab it and put it here. Okay, so here you can satisfy the overshoot criteria. At this point you can satisfy overshoot criteria, but my friend, you need this intersection. You need the root locus to pass through this intersection, where basically your settling time criteria is fulfilled and your overshoot criteria is fulfilled. If I go to the step response, what I will see here, if I see the settling time, what is the settling time? It is 4.16. If I see the overshoot, if I see the peak response, it is 1.16, that is 16% overshoot, which means still the design requirements are fulfilled. Actually, even if I don't do anything, it's fine. Even if I don't do anything, it's fine. But suppose I want to take the settling time to near to 5.5 seconds. Right now, if you see, settling time is what? 4.16 less than 5.5. Overshoot is 16% less than 16.4. So you can say both your design criteria are being fulfilled. But my dear, suppose I want to take the settling time near to 5.5 second and overshoot as 16% or near around to this value, then what will I do? I will insert a lag compensator. So I'll add pole or 0. I'll go to this. What I have done, I have right click here. Then add pole or 0. I will use lag compensator. So see, can you see a cross mark near to my arrow? This is the position of a pole. Suppose I keep it here. So now it has added a lag compensator. Now I can grab this pole and 0 and I can move them around to make sure that my curve passes through this value. Okay. So I will show it to you. Suppose I move it up to here. Just a minute. So see, when I move this pole or a 0, you will see that there is a corresponding change in your curve. Correct? You can see the root locus is changing. Can you see that? I need it to pass through the desired point. Correct? So if you see, it is going away from the desired point. Here you can easily move it. Now suppose I bring it close, this 0 also. or shall I take it further? This is a kind of a hit and trial process. Okay, this is a part of hit and trial process. So basically you can see the response here. So if you see, the response here will be changing, and you can see the peak response. Just let me see if I can move this curve here. So here basically if you see, I think the settling time has reduced by a huge amount. Okay, I think this has become unstable. Okay, because the amplitude of oscillation goes on increasing. So let's see if I can pull it back. Actually I should not pull it back this much, correct, because it is going near to -50. Okay, so you have to keep doing this exercise of moving around the poles and the zeros so that you can see the corresponding change in the root locus diagram. Okay, just a minute. Yeah, so let me zoom in a bit. Okay, you can zoom in just by selecting the particular area, and then you can go to this arrow if you want to move the poles and zeros again. Okay, so that way you can do. Next thing what you can do is, so basically we can move around these poles and zeros, and we can vary this root locus and make sure that it passes through this point, which is the intersection point of our characteristic, and simultaneously we can measure the response. Simultaneously we can measure the response. Okay. Just a minute. Why is it becoming unstable? Now see, you will always see corresponding change in your step response. Okay, see, this is changing continuously. It will change as you move around the poles and zeros, na? It is going to change regularly. See, constantly it is changing. Okay, so that is a basic exercise that you can do at your own end. So basically guys, here what you need to do is, you need to basically move around the poles and the zeros to make sure that your root locus passes through the intersection. Okay, so here you can move around these poles and zeros in order to make sure it passes through the intersection. We have entered the correct transfer function, right? S plus 3, S plus 6. I think yes. Okay. So guys, and simultaneously you can see the step response if it is satisfying your requirement. Once that happens, then you can export the current design. From where you can export it, let us see. Design. I think C means compensator, or F. Just a minute. Control system. Can you export the design from here? Edit architecture, tuning methods, analysis. Yeah, here it is export. So here you can export the tuned blocks to the Matlab, application. So it will open up a window of export model. Okay. Yeah. So it will be exported to the Matlab. Okay. We need to select the models that we are exporting. Okay. Suppose I have selected FCGH. Okay. So basically see, here you get the, so what will be the compensator? F is the static gain. C is this. So this is the your compensator transfer function that we designed. So basically you will move the poles and zeros graphically, you will export it to Matlab workspace, and then you can check for yourself what is the transfer function of compensator. Same way you can do for lead, just instead of lag you have to select the lead when you are applying a compensator. And guys, if you want to learn more about compensators conceptual part, then you can watch my playlist on this very YouTube channel. You can watch all the lectures and you will get to know control systems in great detail. And my friend, you can also join Unacademy Plus, where you get live classes by top educators. You get crash courses and comprehensive courses, and not only this, you get daily assignments, weekly tests, test series, question bank, and your doubts are also cleared. In one subscription, your preparation for GATE, engineering services, semesters, PSU, and state assistant engineer will be covered. And in case you miss any classes, you can watch it recorded as many times as you want. But if you want to fly higher, go with Iconic. Here all plus benefits along with a personal coach are included, who himself is a GATE and ESE topper, will guide you step by step how to plan your studies, create your schedule or a planner. Teachers will guide you, motivate you, inspire you in study booster session. You will get test analysis, study material, and you will get a dedicated team to clear all your queries. So if you use the code Ankit ESE, you get immediate 10% discount and you come under my personal guidance. And my dear, we have started a new batch in which I am teaching measurement daily at 7:30 a.m. So you guys can join this batch, you guys can attend this batch, and you can learn measurements from me directly. The next subject that will be starting in this batch will be the digital electronics. And my friend, after measurement, I'll be directly diving into machines and power system. So that is why you need to join immediately. Okay, and ECE guys, Suresh sir has started EMFT for you all. So EC people can also join Unacademy right now. Their core subjects have been started, and Vishal sir will soon be starting communication. And my friend, on 6th of June actually, at 11 a.m. you will have a combat test. That is a free test on Unacademy app. You can enroll it using the code Ankit ESE. By this test you can judge your preparation level, and if you do well, you can even get 100% discount on Unacademy subscription. With Ankit ESE code, your 1 year fees would become 27,225, 18 months 34,650, and 2 years 39,600 if you go for plus. Now you can pay this fees in installments, 12 equal installment without interest, and even if you cannot pay these installments, you can either take a loan from Unacademy. In case you can't get a EMI on your debit or your credit card, Unacademy will give you an education loan which you can repay later. With Ankit ESE, iconic 1 year fees would be 45,225, 2 years 66,600. Again beta, I would suggest that you go for 2 years so that you get maximum benefit at minimum price, and there are more possibility of cracking any exam. This is my Unacademy profile, Ankit2047. So follow me. You can message me as well. And my Telegram channel, in order to stay connected to me, is this t.me/gateair1. Okay, this is my Telegram channel. So thank you everyone. I hope you liked the video. Please don't forget to like, share, subscribe, and leave a comment below the video as to if you like the video or not. And I'll see you soon with another video on control systems. Thank you.